In the last session, actually, we have solved a problem in which the projections was completely known, or the projection was given. That is, when the complete projection is given, what in the question, the distance between the projectors will be given. The distance of the points from HP and VP will be given. So all these things, all these data gives you the idea about, or gives you the sufficient information to draw the entire projection only. Then from the projection you have to find out the true length, true inclinations, etc. That was the problem that we discussed yesterday or the last class. In today's session, a variant of the same type of problem. A slight difference in the data given is there, but a similar procedure is there. But since the data is different, the shape of the figure, the shape of the drawing that you complete will be slightly different. So let's see an example which is slightly different. Okay. So the question is, a line AB has its point A in HP and 30 millimeter in front of VP, and point B is in VP and 60 millimeter above HP. The distance between the end projectors is 70 millimeter. Draw its projections. Find the true length of the line and its inclinations with the HP and VP. Also find its traces. This is the question. So in this case, the line is AB and its point A is in HP and 30 millimeter in front of VP. So the position of this point A is given. Then point B is in VP and 60 millimeter above HP. So the position of B is also given. So, and the distance between the end projectors is 70 millimeter. So all these things that we discussed in the previous example, it's given here also. That is the position of A as well as position of B and the distance between end projectors. The only difference is the values that is given is slightly different. So just to note down the question and then we can solve it. Now let's mark all the information or all the data that is given in the question in our base figure. So this is our base figure. In this case, that given data is the position of A. Position of A is in HP. So this distance, since A is in HP, this distance should be equal to 0. This distance should be equal to 0. Since A is in HP, the front view of A, that is A dash, should be on XY line. Since A is in HP, A dash, that is the front view of A, should be on XY line. So this particular distance should be 0. Then it is 30 millimeter in front of VP. So the top view should be 30 millimeter below XY line. So this distance should be 30 millimeter. So that two conditions we are already got. Then B is in VP. B is in VP means the top view of B should be in XY line. So this distance should be equal to 0. So that is the top view should be lying on XY line. The top view of B should be lying on XY line. So this distance should be equal to 0. And it is 60 millimeter above the HP. So this distance should be equal to 60 millimeter. So B dash should be 60 millimeter above XY. So this distance should be equal to 60 millimeter. So A dash, the distance of A dash from XY should be equal to 0. And the distance of A from XY should be equal to 30. And the distance of B, small letter B from XY should be equal to 0. And the distance of B dash from XY should be equal to 60 millimeter. So this is the data that is given. Then the distance between the end projectors, that is the distance between these two projectors, should be this distance. This distance should be equal to 70 millimeter. So this is the data that is given. Now we can start a drawing by locating A dash as well as A dash as well as A, and then draw the second projector 70 millimeter away from the projector of A, and on that one you can mark a 60 millimeter and 0, that is B is on XY line, so that you can mark. So the projections are completed. Then you have to rotate the projections, that is AB, so that it will be parallel to XY line, and then find out B1. Then from B1, using the locus of B dash, find out B1 dash. So join A dash and B1 dash in order to get theta as well as the true length line. Then you rotate the front view, that is A dash B dash, such that B2 dash is obtained. Then from B2 dash projected to the locus of B, so that you will get B2. Then join A and B2. There also you will get the true length and the true inclination phi. Then you locate the H dash, the point H dash and HT. Then locate the point V and VT. So this is the procedure. So I'll show it by drawing in the open board software, and then you can continue, you can follow with me. That is, whatever I am drawing, you can repeat it. So now let me insert the base figure. So this is the base figure. Now, since the base figure is there, I want to mark the actual values. That is here, this distance to A dash, this is 0. Distance to B is also 0. This is 30, and this distance is 60. And the distance between the end projectors, this value is 70. So this is the given data, and based on this one we will complete the drawing. Okay. Now first we have to draw our straight line, that is our XY line. So take the ruler and draw the XY line. XY line should be a bit darker or a thicker line. So first draw a horizontal line, which is our XY line. So mark it as X and Y. So you follow the procedure, follow the same steps that I am doing. X and Y is drawn. Now what we have to do is we have to draw a perpendicular line, so that we can mark A dash as well as A on it. Since the distance between A dash and XY is 0, so we can mark A dash somewhere here. So we mark A dash as this point. This is our point A dash. So here is A dash. And now from A dash, we have to draw a perpendicular line. This perpendicular line is to mark point A. So we mark 90 degrees here. And then join a straight line. So in order to draw the straight line, you use the scale. I'm just drawing it like this. Okay, the straight line is drawn. Now on this straight line, 30 millimeter below XY line, you have to mark A. So 30 millimeter below the XY line, you have to mark the point A. So here it is. So here is the point A. So A is here. Now A dash is here as well as A is here. Now we need to draw a horizontal line. I mean, actually, another projector which is making an which is at a distance of 70 from the first projector. So from here you mark a 70 millimeter distance from this point. From this line you mark 70 millimeter distance, and through this particular point or through this particular point you can, okay, instead of marking it there, it is always better to mark it on the XY line itself. Otherwise you may not be able to perfectly draw the perpendicular line. So mark the distance on, mark the point on XY line. Okay. Now from this point draw a perpendicular line. Here also I am using a straight line is drawn, and on this straight line mark a distance of 60 millimeter. 60 millimeter, since the point B dash is 60 millimeter above HP. So you mark a distance of 60 millimeter above this one. So this is, here is point B. This is the point B, and here is the point B dash. So now we go obtained all the points, all the required 4 points, A dash, A, and B dash, and B. All the 4 points we are obtained. Now join these points using straight lines, thicker straight lines. So join A dash with B dash. So this is our front view, and A with B. So this much we have obtained. Now from this one we can mark the locus of A dash, locus of B, locus of B dash, as well as locus of A. So this XY line itself is the locus of A dash as well as locus of B. Since B and A dash is lying in the XY line, so XY line itself is the locus of B as well as locus of A. So we can mark this line. This is locus of A dash and B. So XY line is the locus of A dash and B. So I am putting it on the right side. Sorry, I mean on the left side. So here is it, locus of A dash and B. Now locus of A is a line which is parallel to the XY line and passing through A. So here you can draw the locus of A. So this is the locus of A. And the locus of B you can obtain, locus of B dash you can obtain by drawing a horizontal line or a line which is parallel to the XY line and passing through the point B dash. So this is the locus of B dash. So these lines can be obtained from, or these things can be obtained using this figure, this base figure. From the base figure, you know that the point B dash and the locus of B dash, the relation between B dash and locus of B dash, you know. the locus of B as well as locus of the and B, point B, the relation you know. Likewise, you can find out all these relations using this base figure. So locus of B dash as well as locus of B and locus of A as well as locus of A dash. All the four loci we have drawn. Now what we have to do is we have to rotate AB so that AB will be parallel to XY. Parallel to XY means it will be lying in the locus of A. So in order to do that, we use the compass and fix it at A and take the radius equal to the length AB. And then from there and using this particular radius, you draw an arc. So like this, the arc should be, when you are drawing, it should be from the opposite direction, but in this case, it is very difficult to draw like that. So by drawing this arc, you can get B1. In our base figure, even though B is here, B is in this position and B1 is here, in this particular figure, B is in XY and B1 is somewhere away from XY line. Since A is away from XY line, so B1 will also be away from the XY line. So this point is B1. Now B1 dash, you know, B1 dash is a point which is lying on the locus of B dash. B1 dash is a point which is lying on the locus of B dash. So from this point, you draw a vertical line, a line which is perpendicular to the XY line and which intersects with our locus of B dash. So actually we haven't marked the locus of B dash. This is locus of B dash. And here is locus of A. Here is locus of A. And this point is point B1. We obtained the point B1. And here, this point is actually B dash. So the point B1 is, from the point B1, we obtain point B1 dash. B1 dash. So this is the point B1 dash. Now join B1 dash with the locus of, with the A dash. Join B1 dash with the A dash. This is the line. So A dash B1 dash will give you the true length. A dash B1 dash will give you the true length in this case, as well as this angle. This angle will give you the true inclination. This angle, the angle of A dash B1 dash with the XY will give you the true inclination. So you just find out what is the true length as well as the true inclination. True inclination in the front view, that is it. So here it is theta, true inclination in the front view. And this larger angle is alpha. This larger angle is alpha, that is the angle which A dash B dash makes with the XY line, that is alpha. And this smaller angle, that is theta, that is true inclination with the HP. Now we need to find out the true inclination with the VP also. So in order to do that, we have to rotate the front view, that is A dash B dash. Take the radius equal to the radius of A dash B dash, I mean the length of A dash B dash. Then rotate it so that it becomes parallel to XY line. In this case, parallel to XY means the locus of A dash and the locus of A dash is xy itself. So draw an arc like this, that is from A dash B dash, draw an arc such that it intersects with the xy line. Here it is, xy line itself is our locus of A dash, and this point is B2 dash. This is the point B2 dash. Now from B2 dash, drop a perpendicular to actually drop a projector to x, the locus of B. Here locus of B itself is locus of A dash. So here B2 dash as well as the locus of B are lying on the same line. So that means B2 dash itself will be the B2 point. The point B2 will be equal to the point of B2 dash. So we place B2 here. B2 as well as B2 dash is the same point, since the locus of B and the locus of A dash is the same. Since the locus of B is same as the xy line and B2 dash is on the xy line, B2 as well as B2 dash will be the same. Now join B2 A with B2. Join A with B2 using a straight line. So now this length, this AB2 will be the true length. It should be equal to A dash B1 dash. Slight variations is possible, that is 1 millimeter or 2 millimeter is possible, and more than that means there is something is wrong with it. So now this angle is the true inclination with the VP, that is phi, and this angle is beta. So this is the complete drawing. Now you have to locate the HT as well as VT. Here HT, in order to find out HT, you must first find out H dash. H dash is obtained by extending the front view A dash B dash, such that it intersects with the XY. So here A dash B dash, we need not extend A dash B dash, since A dash is lying in the XY line. A dash itself will be the point H dash. So that is the point H dash. A dash itself is the point H dash, since A dash is lying on XY line. Now HT will be the same point as A. So this point A will be the same as HT. Why? Since we are projecting this H dash to the extended top view. Here we need not extend the top view, since A dash is the front view, I mean H dash, A dash itself is the front view for the point which is lying in the XY line, that is H dash. So HT will be the same as A. So you don't have to extend AB. So that is why H dash is A dash and A is HT. Similarly, V will be the same as our B. Similarly, when we extend, here we obtain V, point V by extending the top view. Here we need not extend the top view, since V is in, B is in XY. We need not extend the top view. It is already intersecting with the XY. So V itself is obtained as B. And then VT. VT will be same as our point B dash. So this will be our point B dash. VT as well as B dash will be the same point. So this is the completed drawing, and then you have to mark the dimensions also. The dimensions of A from XY line and B from XY line, then the distance between the end projectors, and finally you have to draw the box and mark all the dimensions that is required, that is set, that is the true length, true inclinations with HP, and true inclination with VP, alpha as well as beta. So this is how it is being drawn. I hope you might have completed it. Else, I'll show the PowerPoint presentation. In the PowerPoint presentation, there is an animation. So that animation also you can see. So first you draw the XY line, X and Y. Then you mark the point A dash. Then drop a projector to mark the point A. And from this projector, that is the projector for A and A dash, mark distance 70 millimeter. And on this particular projector, mark a point B, and on the projector above XY line, 60 millimeter above the XY line, mark point B dash. Now join A and B, that is the top view, A dash and B dash, the front view. Then the front view length and the top view length is marked. That is not necessary in our drawing. It is for reference purpose only. Then alpha as well as beta is marked. Now we rotate the front top view AB such that it becomes parallel to the XY line. Parallel to XY line means through the locus, it should be lying in the locus of A. So this is point B1. The dissimilarity between the two figures is because of the data, the base figure as well as our actual figure. The dissimilarity, that is, it is not similar. It is just because the appearance is not similar, but the concept is similar. Concept is similar because the difference is that in the base figure, what we considered is A is closer to HP as well as closer to VP, and B is away from HP as well as away from VP. But in this case, it is something different. In this case, A is in HP and away from VP, but B is in VP and away from HP. So that is the difference. So B1 we obtained, then the locus of B dash we found out, and then from B1 we project B1 dash. So we obtained B1 dash, then join A dash with B1 dash. This length A dash B1 dash will give you the true length as well as the true inclination with the HP. So that is theta. So this value you can measure and write down. Now what we do is, now we rotate A dash B dash so that it becomes parallel to the XY line. That is, we obtain B2 dash. B2 dash will be in the locus of A dash. So we obtained B2 dash. Then B2 dash and B2 should be in the same projector as well as B2 should be in the locus of B. Here locus of B is same as XY line, and B2 dash is already lying in the XY line. So B2 dash as well as B2 dash as well as B2 should be the same point. So B2 we obtained, then we join A and B2. So this is again a true length line, and then we mark the angle. This angle is phi, that is the true length line. The angle that the true length line AB2 makes with the horizontal line AB1. So that is the inclination phi, that is the true inclination. So now the dimensions are marked, 30, 60, 70 is already marked. Then finally you have to mark all the dimensions in a box: TL, theta, phi, alpha and beta. Okay, I hope you completed it. Now somebody just unmute and tell me the values of true length, theta, phi, alpha and beta, so that others can get an idea about what their fellow students got. What is the true length?
10 centimeter.
10 centimeter. So when we are writing, we are not writing it as 10 centimeter.
100 millimeter.
Pardon?
100 millimeter.
100 millimeter, yes. Always write it in millimeters. So 100 millimeter. Then theta?
98, okay.
98 is okay. 2 millimeter up and down is okay, no problem. 100 means 98, even 97 is also okay. If it is 95, then you have to recheck your drawing. If it is 105 also, you have to recheck the drawing. Otherwise, it is okay.
45 degree.
Theta is 45 degree. Okay, 5.
5 is 18 degree.
18 degree. And alpha and beta?
Alpha 49 degree.
49 degree, okay. Then beta?
23 degree.
23 degrees. Okay, good. I hope all of you got the values somewhere near, or plus or minus 1 degrees is okay. That is 45 means 46 is okay, or 44. That slight variations comes while we draw, while we taking the measurements because of some errors in our instrument, etc., etc. So that sort of things happen. Never mind. So I hope it is complete.